In this video, we're going to do an example problem using the meshgrid function. It's one of the textbook problems from chapter 4, I think. So here we're told to find areas of rectangles with lengths 1, 3, and 5, and widths 2, 3, 6, and 8. Now, just a reminder, what the meshgrid function does, it will take two or more one-dimensional vectors, for instance length and width in this case, and it will turn it into two-dimensional matrices of same size. So that's just a reminder. So to approach this problem, the first thing we would do is you would assign the vector length and width. So I'll call it L for length. So length is assigned the elements 1, 3, and 5. And width is assigned the elements 2, 3, 6, and 8. Now once again, if you're trying to find area, you do length times width. So area is equal to length times width. But you will notice that you can't do that, and that is because L and W have different sizes. This is of size 1 by 3, and this is of size 1 by 4. So you can't do that directly. What you would have to do in this case is use the meshgrid function. So on the left hand side, meshgrid would accept two variables, and on the right hand side it will accept two vectors. So we'll send vector L, comma W. So we'll send it two vectors on the right hand side, and on the left hand side we'll assign two more variables for two matrices that we expect to get back. So we'll call this L new, comma W new. So what this will do is it will take these two vectors and then turn them into matrices. And if you look at the last video, I explained how this works. I guess I can do it again. So what it will do is it will create L new and W new. They will both have the same size. They'll be of equal size. The number of elements in W, since W has 4 elements, 2, 3, 6, and 8. Since W has 4 elements, both L new and W new will have 4 rows each. Now since L has 3 elements, 1, 3, and 5, both L new and W new will have 3 columns each. Now if I run this, you see that L new is assigned it's a 4 by 3 matrix, and W new is also assigned a 4 by 3 matrix. L new has elements 1, 3, and 5. So like I said, if you look at W right here, what W new will have is 1 row for each element in W. So W new, if you look at W here, you look at W new here, and then you look at down here. So W new will have 1 row for 2, 1 entire row for 2, 1 entire row for 3, 1 entire row for 6, and 1 entire row for 8. And how many columns it will have is dependent on L. Since L has 3 elements, this will have 3 columns. Now similarly, you go up to L new here, and you look at L here. So since L has 3 elements, you know that L new will have 3 columns. 1 column just for 3, one column just for 1, 1 column just for 3, and 1 column just for 5. So 1, 3, and 5. And how many rows it will have will depend on the number of elements in W. Since W has 4 elements, this will have 4 rows. So hopefully that made sense. Now that you use the meshgrid function, you can go ahead and multiply you can go ahead and multiply L new by W new to get all the possible areas. So when you multiply this together, you get 2, 6, 10, 3, 9, 15, 6, 18, 30, 8, 24, and 40. Now these aren't just random numbers. Where these are coming from is multiplying this element by this element will give you 2. Multiplying this element by this element, so 1 times 3 will give you 3. 1 times 6 will give you 6. 1 times 8 will give you 8. And then you keep multiplying all the elements in these two matrices and get the answers in this matrix. So taking any length from this and any width from this vector, so taking any L and multiplying it by any W will result in one of these following answers. So this is called list of all possible answers. I guess you can call it that. So this is a list of all the possible answers when you take one element from L and one element from W and multiply them together. So you'll get one of these answers. So, but that was our goal to find for this video, was to find the possible areas. So thank you for watching. See you next time.